Okay, so here we have a plus b to the 5th power. And we know from Pascal's triangle, 5th row, or row 5, we got 1, 5, 10, 10, 5, 1. Those are my coefficients. I'm going to go ahead and put a plus here. All right, that's one pattern. There's two other patterns we need to deal with. The pattern for the first term and the pattern for the second term. The first term here is going to start out to the highest power and work its way down. The second term starts out at the lowest power, which is 0, and works its way up. So we have a to the 5th, a to the 4th, 3rd, 2nd, 1st, and 0. Then on B, it's my second term, I'm going to start out with a to the, I'm sorry, I didn't write a to, I wrote a. That would have been a to the 1st. That's really a to the 0. There shouldn't be an a there. So right now it's still just 1. B, we start out with b to the 0. So we don't have a b. B to the 1st, b to the 2nd, b to the 3rd, b to the 4th, and b to the 5th. Remember, there's nothing here. That was my mess up. Again, when our exponent is 5, this is going to be 5. These two add up to 5. These two add up to 5. 2 and 3 is 5. 1 and 4 is 5. There's 5. So this is my answer. My answer is a to the 5th plus 5a to the 4th b plus 10a cubed b squared plus 10a squared b cubed plus 5a. So here's what happens when you have a negative. If you have a negative in the middle, it still starts out positive and it alternates. Because when we raise -1 to different powers, it alternates back and forth as we're going. Okay, -1 to the 0 is just 1, to the 1st is -1, to the 2nd is 1, to the 3rd is negative, to the 4th is positive. So that's always what happens when you have a minus in the front, in the middle, excuse me. Starts out positive, goes negative, positive, negative, positive from there. So you can pretty much just count on that. You don't necessarily have to go through the process of multiplying this out, but you certainly can if that helps you. Okay, next question is, what if I got a number instead of a variable? Let's look at this. Okay, well, here's what happens is these pretty numbers that we're getting out of Pascal's triangle, they will still be there, but we won't see them. And let me show you what I mean. This is to the 4th power, so 1, 4, 6, 4, 1. Okay, remember the power goes with the row, which goes with this number. So if it's a 4th power, you're using this row. 5th power, this row. 2nd power, this row, and so on. So we have 1, 4, 6, 4, 1. All right, now first term, m starts out to the 4th power and works its way down. This is the 1st power, and this is m to the 0. 3 does the same thing as if there was an n here. It starts out to the 0 power and works its way up. 3 to the 0 is just 1 though, so I don't have to write it. Then this is 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 4th. This is why I'm not going to end up seeing that beautiful 1, 4, 6, 4, 1 in my final answer, is because I'm about to multiply the 4 times 3 and the 6 times 3 squared and so on. Excuse me. So those numbers are still in there. They just don't show up plainly the way they do when we first put them in there, or the way that they do when we have nothing but letters in our binomial that we're expanding. So my first term is m to the 4th. Second term, 4 times m to the 3rd times 3 is 12 m to the 3rd. Third term, 6 times m to the 2nd times 3 squared, which is 9. So 6 times 9 times m to the 2nd. Next term, 3 cubed is 3 times 3 times 3, that's 27. 27 times 4 is 108. So 108 times m. And last term there, 3 to the 4th is 81. And this is my answer. So in the final answer, you can't see the 14641, but it's in there. Okay, let's do another one. This one has numbers, has a 2x. It has actually a term that has a numeric and a variable part to it. And it's also got the minus. So let's do, the 5th power. All right, so 5th power, 5th row of Pascal's triangle. 1, 5, I'll take care of it in a second. You might have noticed I already started to do something sort of wrong. It's not necessarily really wrong, but if we're going to go ahead and just go with the fact that my signs alternate whenever there's a minus, then this is really going to end up being a minus, and this will be a minus. And so will this. So it starts out positive, negative, positive, negative, positive, negative. If you're going to address it the way I just did by just changing the signs, then don't think of this as a negative y, just think of it as a y, because we already took care of the signs. Okay? If you would rather, you can leave it plus and treat this like negative 1y. Either way. But don't change the signs 2 different ways. Either take care of it as a negative 1y, or just change the signs yourself like I just did. So let's see what this is going to do. 2x is going to start out to the 5th power and go down from there. This one we're going to get to see what happens to the numbers in there with it. And that's 2x to the 0. Don't like that marker. Hopefully this one will be better. Then I'm not going to put negative y or negative 1y because I already dealt with the signs. I'll just call it y. So y starts out to the 0. I didn't really need to put that there. That's a 1. Y to the 1st, y to the 2nd, y to the 3rd, y to the skipped one, 4th, and y to the 5th. All right? So my first term, 2x to the 5th, you've got to make sure you raise both the 2 and the x to the 5th power. 2 to the 5th is 32, and then x to the 5th is x to the 5th. Minus, then I've got 2 to the 4th, which is 16. 2 to the 4th, x to the 4th. So that's 16x to the 4th. Let me just go ahead and write that up there to remind myself. 5 times 16 is 80. X to the 4th, y. Plus 2x to the 3rd, 2 to the 3rd is 8, and then x to the 3rd. So 10 times 8x to the 3rd times y squared gives me also 80. X cubed y squared. 2x to the 2nd. This becomes 4x squared, 2x times 2x. 2 times 2 is 4, x times x is x squared. 10 times 4, that's 40 x squared y to the 3rd. 5 times 2 is 10 x y to the 4th minus y to the 5th. And that is my answer. Just think of how much work that would have been if we had to multiply it all out by hand rather than using the patterns that we get out of Pascal's triangle. And that's pretty much all there is to it.